For the lesson today, we are looking at solving quadratic equations. This is a continuation of the last lesson, which is talking about factorization. So, by the end of the lesson, you should understand the zeros of a quadratic function is the roots, or the x-axis intercepts. You must be able to understand that some quadratic functions do not have any roots at all. In this case, this is what we call the irreducible quadratic functions. You must be able to use the procedure of completing the square and the quadratic formula to solve quadratic equations. And finally, you must be able to identify the discriminant of the quadratic formula and recognize its significance in determining the number of the roots of the quadratic functions. Now, we all know that quadratic function in the general form is y equals to ax squared plus bx plus c. And a does not equal to 0. So, when we solve for ax squared plus bx plus c equals to 0, this is when y equals to 0. That is the time where the quadratic equations actually crosses the x-axis. So let's have a look at when we plot the any quadratic equation. Alright, started off with the xy axis. So for any quadratic functions, y equals to ax squared plus bx plus c, for example this one, we can see that there are actually 2 points when this parabola crosses the x-axis. These are the x-intercepts. What about the second situation? Same thing, y equals to ax squared plus bx plus c. This time, there's only 1 point, there's only one x-intercept. Whereas the third case, y equals to ax squared plus bx plus c, there is actually no intercept at all. Now, just for a summary, the x-axis intercepts, that is when y equals to 0, is actually the roots of the quadratic functions. We can observe that there are quadratic functions with 2 roots. In this case, the 2 roots with 1 root, or there's no root at all. Now, just recall from year 10, we actually started talking about the null factor law. So if a product of 2 variables m and n, mn equals to 0, then m equals to 0, or n equals to 0, or m equals to n equals to 0. So in this case, to solve a quadratic equation, we need to move all terms to the left-hand side of the equation, factorize, and then use the null factor law to solve the equation. If we have a variable or pronumeral which is a common factor, do not ever divide by it. Always factorize first. I will show you the reason why. Now, note that the null factor law can only be applied to quadratic equations with 2 roots and 1 root. You can see that the two numbers should be 10 and minus 3. Therefore, rewriting this, we've got 2x squared plus 10x minus 3x minus 15 equals to 0. So let's take out the 2x here, x plus 5, and take out the minus 3 here, x plus 5. That gives us 0. So 2x minus 3, x plus 5 equals to 0. So therefore 2x minus 3 equals to 0, or x plus 5 equals to 0. X therefore equals to 3 over 2, or minus 5. What about the third one? What I would do is take out the highest common factor first, which is 10, x squared minus 4x minus 21 equals to 0. Then we make it a monic quadratic to solve. 10, let's do it. It's 7 and 3. And it should be minus 7 and plus 3 equals to 0. Since we know that 10 cannot be equal to 0, we can say that x minus 7 equals to 0, or x plus 3 equals to 0. Therefore, x equals to 7 or minus 3. Now finally, let's have a look at the last one. X squared plus 25 equals to 0. Can we factorize it? No. What about let's move 25 to the right hand side. If we have got x squared equals to minus 25, x therefore equals to square root of minus 25. We cannot solve it. And in this case, this is irreducible quadratic functions, and there is no root at all. It's still a valid quadratic function. Try plotting it using your Classpad. Now, what about quadratic equations which cannot be factorized? The best way of doing it is completing the square. Alright? Recall completing the square from last week. Let's have a look at how do we complete the square here. Okay? Now, we know that we need to take the coefficient of x divided by 2n squared. So let's do it this way. Minus 4 over 2 square minus 1 equals to 0. Therefore, x minus 4x, x squared minus 4x plus 4 minus 4 minus 1 equals to 0. So here it becomes x minus 2 square minus 5 equals to 0. X minus 2 square equals to 5. X minus 2 equals to plus or minus square root of 5. So therefore x equals to 2 plus or minus square root of 5. Now it depends on the question. Sometimes you are asked to do give the answer in decimal places, or sometimes you can just leave it as exact value. Alright, in this case, the second question, slightly different. We know that we have to complete the square. So this time what I'm going to do is to take the 2 out. X squared minus 7x minus 5 over 2 equals to 0. Completing the square, 2. X squared minus 7x plus 7 over 2 square minus 7 over 2 square minus 5 over 2 equals to 0. Therefore, 2x minus 7 over 2 square minus, oops, I forgot the square, minus 49 over 2 over 4 minus 5 over 2 equals to 0. So 2x minus 7 over 2 square minus, let's take it to a common denominator, 49 plus 10 equals to 0. So therefore we've got 2x minus 7 over 2 square minus 49 plus 10 is 59 over 4 equals to 0. And then what we need to do is we know that x minus 7 over 2 cannot be 0, square equals to 59 over 4. Alright, so therefore x minus 7 over 2 equals to plus or minus square root of 59 over 4, which is equals to plus or minus square root of 59 over 2. Alright, I'm running out of space, just using this bit here. X therefore equals to 7 over 2 plus or minus square root of 59 over 2, or if you bring it to the common denominator, 7 plus or minus square root of 59. Alright, again, you can actually give the answer in surds, or if you like, give the answer in decimal places. Read the question carefully. Alright, when we look at ax squared plus bx plus c equals to 0, sometimes it cannot be solved by factorization. So we can use completing the square, or use the quadratic formula, which is this formula over here. Very important for you to know this. You don't need to memorize it. It's given in the formula sheet. So x is equals to minus b plus or minus square root of b squared minus 4ac over 2a. So all this are actually, a is the coefficient of x squared, b coefficient of x, and c is a constant. Right? Let's see how we actually derive this formula. So we know that ax squared plus bx plus c equals to 0. We can rearrange it, thinking about completing the square, dividing everything by a. So if we complete the square, we know that this is the case. We need to b over 2a needs to be divided by 2 and then square it. Therefore, we have this equation here. Now, we know that this actually is a constant, and we can factorize this into a perfect square, which means the perfect square is this, and this expanded is minus b squared over 4a squared. Alright, next step. Moving this to the right hand side by taking away all this. Right? Add one of these and take away c over a. Therefore, we have this new equation, or actually not new equation, it's just an equivalent equation. And by taking square roots on both sides, we know that, oh, actually before that, if we actually bring this into the same common denominator, we got 4a squared as the denominator and b squared minus 4ac. Alright, taking square root on both sides, so therefore x plus b over 2a is plus or minus square root of b squared minus 4ac. Of course, square root of this is 2a. We can rewrite, moving b over 2a to the right hand side. Therefore, we have got x equals to b minus 2a plus or minus b squared, square root of b squared minus 4ac plus 2a. Now, this is a formula, like I said, that you need to know. However, before we actually apply this formula, I want to show you what is important about b squared minus 4ac. Alright, let's have a look. Let's calculate b squared minus 4ac for the following three quadratic expressions. I'll give you a few minutes to do it. Why don't you pause the video here and do it? Alright, time's up. Let's have a look at expression 1. So we know that a is 1, b is plus 6, c is minus 12. And working that out, you know that b squared minus 4ac is minus 84, or 4 square root of 21. What about number 2? Is square root of minus 12. And finally, for 3, is actually square root of 0. Now, looking at this, if x squared plus 6, x minus 12 equals to 0, can we solve it? We can't really factorize it, but we can solve it by either completing the square or using quadratic formula. Here, the 4 square root of 21 or square root of 84 just tells me that we have x will be equals to minus b plus or minus square root of 84 divided by 2a. Alright, so therefore we know that there are two roots. This one, minus 12, we cannot evaluate minus 12. So therefore, there are no roots for this one. So we have, if we write it in the quadratic formula, we've got minus b plus or minus square root of minus 12, which cannot be evaluated. Whereas in this case, for expression number 3, x equals minus b plus or minus square root of 0 over 2a, which means x is minus b over 2a. That's only one value. That's only one root. And you can see that x squared plus 6x plus 9, actually, if you factorize it, is x plus 3 squared. Right. Let's try to apply the formula. So actually, before that, in conclusion, if b squared minus 4ac is less than 0, there is no solution for the equation of ax squared plus bx plus c, or there's no roots. For a positive number, there are two solutions or two roots, and when it is 0, there's only one solution or one root. All right, it's two roots. No root and one root. All right, so b squared minus 4ac is actually known as the discriminant of the quadratic. Right, let's use the quadratic formula to actually solve these two quadratic equations. Now, the very first one, we know that a equals to 1, b equals to minus 7, and c equals to 12. So therefore, if we calculate b squared minus 4ac, we know that b squared is minus 7 squared minus 4 times 1 times 12, which is 49 minus 48 equals to 1. So therefore, x is equals to minus b minus 7 plus or minus square root of 1 divided by 2 times 1. And that is minus 7 is 8 plus or minus 1 divided by 2, which is 8 plus 1 is 9 divided by 2, or 7 divided by 2, 7 over 2. Alright, pause the video for a while and try the next question, please. We know that a is 1, b is minus 3, and c is minus 1. So b squared minus 4ac is minus 3 squared minus 4, a is 1, c is minus 1. So 9 plus 4 equals to 13. So x therefore equals to minus 3 plus or minus 13 over 2. 2 times 1 is 2. So therefore this is 3 plus or minus square root of 13 over 2. That will do. That's the answer. Unless you're asked to use work it out and give the answer in 2 decimal places. Alright, let's try solving x squared minus 10x minus 3 two ways, either the quadratic formula or completing the square. So if I start off with a quadratic formula, we know a equals to 1, b equals to minus 10, and c equals to minus 3. So therefore x equals to minus b minus 10 plus or minus b squared minus 10 square minus 4 times 1 minus 3 over 2. Therefore that is 10 plus or minus square root of 100 plus 12 over 2, which is 10 plus or minus square root of 112 over 2, and that is 10 over 2 plus or minus square root of 112 over 4, which is 10 over 2 plus or minus square root of 28, or actually that should be 5, not 10 over 2. Alright, so that is 5 plus or minus square root of 4 times 7, which is 5 plus or minus 2 square root of 7. Let's try completing this. Right, let's have a look at doing solving this equation by completing the square. So we know that x squared minus 10x plus 10 over 2, which is 5 square minus 5 square, minus 3 equals to 0. Therefore, x minus 10x, x squared minus 10x plus 25 minus 25 minus 3 equals to 0. X minus 5 squared minus 28 equals to 0. X minus 5 squared equals to 28. X minus 5, taking square root, is plus or minus square root of 28. So therefore x equals to 5 plus or minus square root of 28, which is the same as 5 plus or minus square root of 2 square root of 7. So in many ways, it doesn't really matter whether you use quadratic formula or whether you use completing the square. Now, what about using Classpad? You can actually try using Classpad to solve this. Use solve. Alright? Now, make sure that your calculator is either on standard or decimal if you want to give the answer in 2 decimal places. Alright? So have it in decimal form. If not, the standard form will actually give you your search solution. Alright. When you solve quadratic equation, if you can, you need to check whether you can factorize the equation. If yes, solve the quadratic equation by factorizing. If not, solve by completing the square or quadratic formulas. Sometimes you have to use the discriminant to determine whether you can solve whether there's any roots at all. Alright, so this is the end of the lesson. Hopefully I have covered all the objectives that I wanted you to learn.